standard form today, so let's look at that first. Let's look at the steps. First of all, you guys know that the axis of symmetry is if you were to fold the parabola in half along its axis of symmetry, the portions of the parabola on both sides would match, right? It's symmetrical. So really, you only need to know one side of a parabola or a quadratic function in order to figure out the other one, because you can just use that symmetry. So if you just found the positive side, you could easily find the negative side. All right, so that's basically what that's saying there. So if we're going to graph a quadratic function in standard form, we have a few steps here. You're going to find the vertex and plot that ordered pair. I'm throwing things at you. Sorry. All right, so to find the vertex, we use x equals negative b over 2a. And then we plug that in to find the y value. And then you're going to graph and label the line of symmetry, which is the same thing as the axis of symmetry. We get it out of here at 15, right? 8:15. So determine your a value. That's just looking at the standard form equation. So we know that the standard form equation is y equals ax squared plus bx plus c. So all you need to know here, guys, is this point here. That a value. That a value is your multiplier. It will compress it or stretch it. Have you heard those words yet? Compressing and stretching? So if it's a number greater than 1, it stretches it. So if a is greater than 1, it's a stretch. And if a is between 0 and 1, it's a compression. So basically we're saying if the absolute value of those things are between them. So remember, compressions make it wider. So if it's fractional, a fraction between 0 and 1, it makes it wider. And if it's a number greater than 1, the absolute value of that, and it's greater than 1, it makes it more narrow, right? It makes it taller. So those are things that when you guys are doing that a value, and we're talking about this pattern here, this graphing from the pattern, that's your multiplier, okay? That's your compression or your stretcher. So notice typically when we're doing this, 1 squared is 1, 2 squared is 2 or 4, 3 squared is 9. Do those numbers look familiar to you guys when you're talking about going out 1, out 2, up 4, out 3, up 9? Does that seem familiar? Mm-hmm. You guys seem to be doing fine when a is 1. It's when you guys have a number that stretches it or compresses it, okay? So something other than 1. That's when you have to take those numbers and multiply those a values. So we'll talk a little bit about that. Make sure I get to that example before you guys leave today. Which one is it? So I'll make sure to get to example 4 today before you guys leave, even if it's different than mine and everything, okay? And so then you just connect to make the U shape. You can do just one side and then use your line of symmetry to plot the other side of the points too. You don't need to do both sides at the same time, but you could, okay? So it's up to you. What questions do you guys have about the pattern? Because I know that's confusing. Do we understand that pattern? What questions do you guys have about compressions and stretching? We go okay there? The only thing that you guys really need to think about when you're doing this is just make sure you're always starting from the vertex when you're doing this out 1, up however many, out so many. You don't start from the next point, okay? Because that can get confusing too. All right, so let's look at this one. So it says graph each quadratic function, determine the vertex, axis of symmetry, the zeros, and the y-intercept. Before we move on, what is another word for zeros that you could use? Roots. What's another one, is it? What intercept are the zeros? X-intercept. So just realize that zeros is an x-intercept, a root, whatever it is that you hear. Those all are interchangeable words. Okay, so example 1 says find the vertex. So Spencer, how do I find the vertex of y equals x squared plus 6x plus 2?
Put the equals 6
Good, so we have a b in there, so that's negative 6 over 2 times 1. So that's negative 6 over 2, which is negative 3. So our x value is negative 3. That's what we got so far. So how can we then go about, Sarah, finding the y value? Yeah, what is very important when you go to plug in numbers into the x value? What is very important to do, especially before you use your calculators? What should you always use? Yeah. Yeah, put it in parentheses, because negative 3 squared and parentheses negative 3 squared are two different numbers. So you're going to get the wrong thing, so always put it in parentheses. So we have y equals negative 3 squared plus 6 times negative 3 plus 2. And technically, if you have a calculator like this or one of the Casio ones, not yours, Jill, sorry, you can plug it, yeah, that one. You can plug it all in at once, okay? You don't have to do all the steps. Now, Jill, you'll have to do it in order of operations, okay? Just to be able to do it. So we get negative 3 squared is 9 minus 18 plus 2. So that's negative 9 plus 2, which is negative 7, right? So we have a vertex at negative 3, negative 7. Okay, look at that. Because if you can't find the vertex, you're not going to be able to graph this at all. So what questions do you guys have about finding this vertex here? What questions do you guys have about finding the vertex? Anything? Yeah.
So we have to solve it even though we have the vertex and it has the x value?
You have to know the y value in order to be able to plot the vertex, because you're plotting on a two-dimensional graph here, so without the y value, you would just have a negative 3.
I mean, it says negative 3 and negative 7, so can you just like, put negative 7 down with knowing the y value?
So are you asking about this part here?
No, that, yeah.
You have to write, the vertex is an ordered pair, so you have to write down negative 3, negative 7.
Okay.
Yeah, it's the point where what you're going to plot, and since it's a point, you have to plot it that way. Did I answer your question or no? I feel like I'm not answering your question. Are you asking that do I have to do all of this work? Do you understand that I have to do all this work? You don't understand that I have to do
No, I
it.
do understand.
Okay, because you have to do both of those. Okay, so ask one more time.
Can't you just bring down the negative 7 x symmetry?
No, because that's not the axis of symmetry. You're going to bring down the negative 3 to the axis of symmetry. That's what you're asking me. Okay, that's not the answer to that part. Yeah, Jenny.
How do you figure out A and B?
A and B. So a standard form equation is y equals ax squared plus bx plus c. So there's a 1 in front of there since it's not there. So a is 1 and b is 6. Always take the sign in front. Did I finally answer your question? Thank you. Sorry about that. Okay, so that's not the answer for this one here. That's just the work from above, right? And we said the x-axis of symmetry is the x value of the vertex. What's the x value of your vertex? And it's always an x equals equation, so that's x equals negative 3 because it's a vertical line. So always make sure you put that x equals in there. What is your a value? What is my a value here? Alexis, what is my a value? So you can look up here how I put ax squared plus bx plus c. What is my a value? But what number is in front of it? 1. So our a value is 1. This is our multiplier. Okay, this is the multiplier when you go to do the pattern. Although when you multiply by 1, does it change anything? No. Now, so will it stretch it or compress it from the parent? No. So we're going to determine 3 points we're going to use besides the vertex that we can use to graph. Now, we're probably not going to be able to graph all of them, but just to get you guys in the habit. So we know that our vertex point is negative 3, negative 7, right? You guys understand that? So we're going to have that point there. We're going to determine 3 more points from that vertex, okay? So 1 squared equals 1. Our multiplier is 1, so we're going to go out 1, up 1. So let's actually graph this first. We're going to go one at a time. So plot negative 3, negative 7 so I can go through this with you guys. Okay, so our multiplier is 1. Do you guys all understand that we're not stretching or compressing it? So we're saying when x is 1 and we square it, it's still going to be 1, right? So you're going to go out 1, up 1 from the vertex. And I'm just going to do the one side for now. We'll use the line of symmetry when we're done here. Okay, so 2 squared is 4, right? What's our multiplier? 1. So we're going to go out how many and up how many? So this is your out number here. Out 2, up 4. So the number that you're squaring, that base value is your out number. The answer you get after your multiplier is your up number. So we go out 2, up 1, 2, 3, 4. And I know these aren't ordered pairs, but we're not going to worry about that. So if we do 3 squared, we get 9, and we multiply that by 1, it's still 9. So what does that mean we're going to do, guys? Out 3 from the vertex. We always go back to the vertex. Out 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what you guys should have been doing in vertex form. I don't know if you were or not, but this is what you should have been doing. If you can't do it, you can always use a table. But you have this line of symmetry. So if we were to fold it over, shouldn't we have a point over here too? Right? This point is 2 away from the line, right? So if we go 2 away from the line over here, that's right here. And this point is going to be 3 away from my line. So if I go 1, 2, 3 away from my line, I'm over here. Do you guys see that? That line of symmetry allows us to do that. And then what we need to do from here is connect our parabola. Always keep going until you get a y-intercept too, so you can figure those things out. All right, so before I move on, questions on how to graph it. Because some of you guys were looking at me like, I've never seen this before, and you should have seen it before. So, yes, Jen.
You said when you go for the 2, 2, or whatever, you said you go up 4,
You always go back to the vertex. So if I go out 2, I'm going up 4. So you did it from the previous point. Always go back to the vertex when you do things. Does that make sense, guys? That's a good question. Any other ones with the graphing? All right, where's my y-intercept at? Kelly Etheridge. Oh, you're standing. Never mind. Kelly Kavanaugh. It's at 0, 2, right? Okay, where are we crossing the x? Where's my zeros at? Where are we crossing the x-axis at? This is not an x-axis crossing, that's just your axis of symmetry. So it's between 2 points, right? So, Spencer, what 2 points are we between?
-5 and -6.
So I think this is how they had you guys writing it. And -1 and 0? Is this how you guys have been writing it? No? Have you just been saying between 2 points? Okay, if you write between, I know that's not how you spell between, -6 and -5, and -1 and 0, I'm fine with that as well. Okay, either one is fine.
We just spent the
Huh?
order pairs. We got something between.
Those aren't ordered pairs, though. That's the thing. So, like, what this is saying is that it's between those 2 numbers. It's not an actual ordered pair. You know, kind of like an interval. That's basically an interval. You know how intervals are very confusing when it comes to ordered pairs when I have you guys do domain and range. It's that thing. All right. Questions there? Before we move on to the next one? Okay. I'll let you guys finish up there. Please be asking questions, because if you can't do this, it's going to be hard for you. Yeah.
So on the 0, it says like, or, yeah. But between -6 and -5.
I don't know how he had you guys doing it. So this is actually the technical way I would prefer it. But because I haven't been here teaching you guys this whole time, I am not going to be as picky about some of this stuff. So if you write it this way, that's fine. If it was just me teaching it, it would be a different story. But I haven't been teaching you guys for the last too much. So.
Since that's just like that, you don't have to figure it out.
No, because we don't know the y value. I mean, we know the y is 0, but we don't know what the x value is. So we're just going to be that's as exact as we can get. All right. Let's look at this one now. So it says graph each quadratic function, determine the vertex, axis of symmetry, the zeros, and the y-intercept. So, Olivia, what is my a value and my b value in example 2? Good. So we do x equals -b over 2a. So that's -2 over 2 times -1. That's negative 2 over negative 2, so our a value is just 1. Or I mean our x value is just 1, sorry. So Iris, what am I going to do to get that back into, or to get the y value of the vertex? Plug the 1 into all the x's, always using parentheses. Okay, so here's where it gets confusing. Where does the parenthesis go in this situation? Does it go before the negative sign or after the negative sign? After. This negative sign is already in the equation, right? We're just plugging in for x. So we have negative 1 squared plus 2 times 1 plus 3. Remember, if you have one of those two calculators, you can easily just plug it in and you don't have to worry. Others of you might have to follow order of operation. So that's y equals negative 1 plus 2 plus 3. So that's 1 plus 3. So our y value is 1 comma 4, or our vertex is 1 comma 4, because our y value is 4. Questions there? Okay, Carly, what is my axis of symmetry? X equals 1. It's always the x coordinate of the vertex. What is my a value this time? Vivian, what is my a value this time? Negative 1. So is this going to stretch or compress it? You're going to do either of those two things? No, because it's still 1, so it's not going to change that. But there is a change. What is a negative 1 going to do, Sarah? It's going to flip it. So the difference here is it's going to be flipped, okay? So our multiplier this time is negative 1, which means we're going to have to go down. Okay, that's really what that's saying. Okay, so we determine our 3 points. So we said our a value is negative 1. So we start with 1 squared, right? Because that's the first thing we do. We go out 1. 1 times negative 1 is negative 1. That's telling us to go down, right? So that's why we're going down there. So I'm going to plot the point 1 comma 4, which is my vertex. And my first step, remember, this is my out, and this is my up or down. And since it's negative, we're going to go down. So we go out 1, down 1. Okay, so then we do 2 squared, which is 4, and if we multiply that by negative 1, we get negative 4, right? So going back to what Jenny asked and what I've been saying, where do you always have to start from? The vertex. So we have to go back to the vertex, go out 2 and down 4 from the vertex. And we'll go one more there. So then it's 3 squared. So that's 9 times negative 1, which is negative 9. That negative means we're going to go down. So we go way back to the vertex and we go out 3, down 9. So we'll be down here at negative 5. And then we can use our axis of symmetry to find the other side of the parabola. So here's our axis of symmetry, right? So we can use that then to plot points on the other side. So this one is 2 away, so I have to go 2 away to the negative 1. This one is 3 away, so I have to go 3 away. 1, 2, 3. And then I can connect my parabola. I know I'm not going through the points, I'm sorry. All right. Avery, where am I crossing the y-axis, y-intercept? Perfect. Jacob, what are my zeros?
1 and 3.
Be careful, it's not 1, it's...
Oh,
You're really close.
-1.
There you go. Negative 1, 0, and 3, 0. It's actually crossing at the points. So what questions do you guys have on that one?
Do you have all the other note packets?
I can get them off the G drive if I need to. Not right now, though, but I will be able to. Okay. let's go to example 4 next, and then we might, if we have time, we'll go back to example 3. I'll do a word problem with you guys tomorrow if you have one on your homework, but I'd rather teach you guys how to graph. So what questions do you guys have right now? Okay, so let's go to example 4 first. And then we'll go from there. All right. Kaylin, what is my A value and my B value?
A is
You're stopping yourself. Why are you stopping yourself? What's weird about this problem?
I don't know.
What's so weird about this problem? It's a little different, isn't it? Spencer, what do you notice?
You have to move the square.
It's not actually in standard form, is it? So, I don't know if you were confused for that reason, but that's a good reason to be confused because it wasn't in standard form. So now can you tell me your A and B value or no? You still confused about what that means? Kaylin, do you know what A and B value mean now? And? There. So it's ax squared plus bx plus c. So that's where I'm getting that A and B from. Does that make sense? Very good that a lot of you guys noticed that wasn't in standard form. I'm very proud of that. That's awesome. All right, so we do x equals negative b over 2a. Opposite of a negative 6 is a? That's why it becomes that. So I get 6 over negative 6, which means my x-coordinate of the vertex is negative 1. Oh, it's because you have to put this whole entire thing in parentheses. Like, you can use the multiplication and put this in parentheses. Because what it did is it followed order of operations. No, that didn't work either. Oh, you didn't put it in, right? You put the B on top, or the A value on top. So do you see how this isn't in standard form here?
Yeah.
So you have to rewrite it in standard form like we did there first. So you chose the wrong A and B value. Does that make sense too?
Yeah.
Okay, so then we plug that back in. So that's negative 1 squared minus 6 times negative 1. So I'm just plugging it into the one above it. You can. It will give you the same answer. It really does not matter. So I have negative 1 plus 6, which is 5. 5 plus 7 is 12, which we're not even going to be able to graph that, are we? We'll have to make it work. Is that what you guys got too? Did you guys get 12 when you plugged it into your calculators? Let's see if I do it this way. So that's 6. Oh, I forgot the 3, didn't I? I did it wrong. I forgot the 3. Don't forget the 3. So that'd be negative 3 plus 6 plus 7, right? So that's 3 plus 7, which is 10, right? There we go. So that's 10. Now we will be able to plot it. Okay, what's the symmetry line? What's the axis of symmetry this time? Sarah Muncie, what's my axis of symmetry this time? What does x equal? Oh, that's fine. Completely fine. Sorry, that's what that says there. Yeah, x equals negative 1. Al, what's my A value this time? What's the A value? So this is the one in standard form. So which one of these numbers is the A value? Negative 3. Very good. So our multiplier this time is a negative 3. So it's going to do 2 things. What are the 2 things it's going to do? It's going to do what, Alexis? I called you the right name. Sorry. I'm still remembering names. So flip it and what else? There's one other thing. Who remembers the other thing? It's bigger than 1, right? The number itself, not the negative, is bigger than 1, so we'll stretch it. So we'll stretch it and flip it there. So we have to multiply by negative 3 this time. So 1 squared is 1. 1 times negative 3 is negative 3, right? So we plot our negative 110 up here. So what that means you're going to do is you're going to go out 1. Negative means down, right? So down 3. So we go out 1, down 3. I'm going to do just one more on this one. So I have 2 squared. 2 squared is 4. My multiplier is negative 3. So that's negative 12. So that means we go out 2, down 12. So if I go out 2 and down 12, we're down here in the negatives and stuff. And so if we keep going, we're not going to even fit on this graph. So I'm going to draw my line of symmetry so I can draw the points on both sides of that line. Okay, Katie, what's my y-intercept? That's 0, 7. Where are my zeros between this time? What are we between? So negative 3 and negative 2 and what? Not 1 and 2, but 0 and 1. Very good. So okay, where are we at right now? Is this making more sense to you guys at all?
Yeah.
Okay, so when we're thinking about vertex form, were you guys confused about vertex form then?
No.
Okay,
That's
so
pretty much all we knew how to figure out was the vertex.
but you guys understand now how to graph it from vertex form then? It's the same process. You know your A values in front, right? Do you know how to find the vertex from vertex form? And now do you understand how to use the pattern? Were you guys confused on how to use the pattern before? Okay. Are you knowing what all this stuff means now, too? What else is in here?
We never learned a pattern.
You were supposed to. So did he teach you the table?
We just he taught us where like if it's plus, it's like right and negative.
Oh, okay.
Something.
All right. Well, I'm going to stop here for today. I'm going to get you guys your